As shown in the figure, a small block slides from point A of the smooth track ABC, in which AB is a part of circle of radius r and part BC is a smooth inclined plane of angle 30°. Find the maximum height attained by the block from the ground. So we will approach the question like this. At first, there is a block kept at point A. So and it will move in the circular path like this way and will come here. So one thing that we are getting, that here it is released. So here it will only have potential energy and here it will only have kinetic energy. It will be maximum and this one will also be maximum. Now with this kinetic energy, it will go upon the inclined plane. From this point it will perform a projectile motion like this. We have to find this height, suppose d. Okay, how we will find this height? At first means like we can assume this as a horizontal projectile, and we can find this one and then add r by 2 to this. So let's start. So we saw that at A, the energy will be the potential energy. Now here we can say that m is the mass of the block, g is the gravitational acceleration, and we can clearly see that h is r. So let's substitute the value. It becomes this. Now we'll find the energy at this point. So it is simply the kinetic energy. So we can represent it as half mv square, where m is the mass of the block and v is the velocity of the block at point B. So let's write half m v square. Okay, so according to the law of conservation of energy, we can equate these two, as we have said that the maximum potential energy is at point A and the maximum kinetic energy is at point B. So let's equate them. We are equating these two. So here the mass of the blocks are same, so we can cancel that, and our v square becomes 2gr. We will cross multiply this to here. Okay. So this becomes our second equation. Now let's check another thing. From B, with the kinetic energy at B, the block will move upon this inclined plane. It will gain some height which is equal to r by 2 as said in the question. So it will both have some amount of potential energy and some amount of kinetic energy. So the energy at B should be equal to the sum of potential and the kinetic energy at point C due to law of conservation of energy? So let's find it out. Which can be equal to half mass of the blocks times v dash square plus m g r by 2. Let us assume the velocity at point C be v dash. So we can equate this energy with the total kinetic energy at point B. So let's equate this v dash square half mv square. So now we will cut half and m. We are getting v dash square plus gr is equal to v square. From the previous slide we can see that the value of v square is 2gr. This one. So we will put this value there. It becomes v dash square is equal to 2gr minus gr, which becomes only gr. Now at point C, it will perform a projectile motion. The angle of projection will be the angle of inclination, that is theta is equal to 30 degree. We got the initial velocity of the projectile as v naught. We got the initial velocity of the projectile motion to be as v naught, and for maximum height we require the equation u square sine square theta by 2g. So we will get the square value. So let's put this and we get gr times sine square 30 degree is 1 by 4, and in below there is 2g. The g and g gets cut, so we are left with only r by 8 here. So h max becomes r by 8. But this is not our answer, as initially I have told that we are taking a horizontal projectile from C. Let me add another ink. We are assuming a horizontal projection from C. So this height is r by 8 and this height is r by 2. So the maximum height attained will be r by 2 plus our h max, which we have found out. So let's find it. That is r by 2 plus r by 8. If you simplify, it is coming 5 5r by 8 as your answer. So it is